Welcome to lesson number 3. We're going to continue factoring trinomials in the form x squared plus bx plus c and using the techniques that we looked at yesterday. Now we're going to be using the method of inspection. And remember, we can start by using our little riddle. What multiplies give me my last term, which in this case would be negative 12, and has a sum of my second term, the coefficient of my second term, which if we have negative x would be negative 1. So what multiplies give me negative 12, but adds give me negative 1. So we could start with, I always start with 1, but as you get better at this, you'll know that you can start with your factors that you know will combine to also give you your sum. So I'm going to start with 4 times 3. And remember that it's negative 12 and negative 1. So one of these needs to be negative. They can't both be negative, otherwise that would result in a positive product. And because it's negative 1, the larger number, or 4, needs to be negative, because negative 4 plus 3 will result in negative 1. This is going to give me x minus 4x plus 3. Next, we'll do this one over here. Again, starting with my riddle, what multiplies, giving me my last term of negative 8 and has a sum of negative 7. So we have 4 and 2, we have 8 and 1. Can't be 4 and 2 because that only combines to give me something close to 6. So 8 and 1. Now, because this is negative and this is also negative, that means one of them has to be negative, and it's probably going to be the larger one, negative 8, because that has to be positive to have a sum of negative 7, so negative 8 plus 1. And we can put those factors into our expression, a minus 8, a plus 1. Also, you're going to be running into problems like this one, where you have a negative value in front of your first term. If you run into something like this, it's easiest to factor that out right away. So then what we are actually factoring is going to be negative a squared. And so everything is going to be having negative 1 factored out of it. So negative 6 divided by negative 1 would be positive 6a, and then 27 divided by negative 1 would be negative 27. So then what we're factoring is going to be everything in here. And so if we do our little riddle again, what multiplies give me negative 27, but adds to give me positive 6. We're going to use 9 times 3, but 9 times negative 3, and 9 plus negative 3. And we'll factor this. We'll end up with a minus 9, or sorry, a plus 9 and a minus 3. So remember, this says factor where possible. So if it's possible to factor. Next we have this expression, 2t squared minus 14t plus 20. Again, we can do something similar where I have a coefficient in front of this t squared, so I can factor out the 2, since the 2, or every term is divisible by 2. So 2t squared minus 7t plus 10. And our riddle here is what multiplies give me 10, adds to give me negative 7. And so negative 5 times negative 2, negative 5 plus negative 2. And we're left with 2, t minus 5, t minus 2. And then I'll skip this one and jump to D. This one appears to not be factorable since 6. If we think about our products or factors to give us a product of 6, we'd have 2 and 3 and 1 and 6. And so we can't combine those to get negative 3. Yeah, so anyway, we just did that one, so that's not factorable. This one, however, we might be able to factor. They're all divisible by 4x squared. So we take out 4x squared, which would leave us with x squared minus 4x and minus 5. Here we have a product of -5 and a sum of -4. So we choose 5 times 1 and -5 plus 1. And so this one is factorable, 4x squared, x minus 5, and x plus 1. Last, we're going to be looking at factoring trinomials of the form x squared plus bxy plus cy squared. Now, the difference here is we're going to end up with a coefficient still as a middle term and last term, but now we have an extra variable that we're working with. So just a little reminder or review, x plus 2x plus 4 can be expanded to x squared plus 6x plus 8. And so then that means that x squared plus 6x plus 8 can be factored to x plus 2 and x plus 4. So if we were to FOIL this, we could expand it to x squared plus 6x plus 8. And if we were to go through our riddle, what multiplies give me 8 and adds give me 6, we would pull out these two factors. So that being said, x plus 2y times x plus 4y can be expanded to, well, if we FOIL it, we'll have our x squared term plus a 4xy term, if I go x times 4y, plus a 2xy term, if I go 2y times x, plus 2y times 4y, which would be 8y squared. And so we could combine these two middle terms. They give us x squared plus 6xy plus 8y squared. And if we can state it as x squared plus 6xy plus 8y squared, using the same reasoning, we can go backwards and end up with our factors of x plus 2y, x plus 4y. And so as an example, we're actually using the same riddle that we were using earlier. This is still solving by inspection. What multiplies give me 30, but combines give me 13. So we have 10 and 3, 10 times 3 and 10 plus 3. Now, the way we would input this into our equation would be x plus 10y and x plus 3y. I'll do this last one, or let's do this one here as well. So we have multiply and sum. So it multiplies give me -72 and combines give me positive 71. So we have 72 times 1 and 72 plus 1. And it looks like it's going to be 72 times -1 and 72 plus -1. And so I'm running out of space in this section, so I'm just going to write it down here. X plus 72y, minus y.